Thank you. All yours, Chuck.
Okay. So, David, thank you very much for that presentation. It described a lot of the things that I do when I'm creating maps, and it kind of gave me a little bit of good feelings that I'm doing some of these things correctly. So what I want to talk about is how we create map, the workflow in creating map messages, map data for our projects in UDOT. So we're using MITS software. And for those on the call that are not familiar with MITS, Multimodal Intelligent Traffic Signal System, and in this case we're using the traffic signal priority portion of MITS. And MITS was designed and created by Larry Head, a professor at the University of Arizona. And for the MITS, for TSP, we're broadcasting SPaT map information. We're also sending SRM messages and SSM messages. So we currently have DSRC deployed on an 11-mile long corridor in Salt Lake City along Redwood Road. And we've got 30 intersections, 25 of them have DSRCs. And the goal of this was to improve the bus that's running on this route from 86% on time to 94%. So I created the map data for these 25 intersections. So what is the NMap file? So when we took over the MITS software from Larry Head and we were porting it across, the map data that's required by MITS is in an NMap file. And what I learned last February when we had the National Conference of Excellence or Center of Excellence in Salt Lake City for a meeting, Larry described that the NMap file came from DARPA Robotics back in the 80s, I think, when they were testing robotic vehicles. And there was really no other standard for putting map data that he could find, so he used the NMap format. So that's been carried along with MITS. And it's an ASCII text file that has all the information in it that David mentioned in his presentation. Our map file, when we take that and our MITS software reads it, we put it in the March 2016 release of the J2735 standard. So in our map file, NMap file, we have intersection information, identification, the attributes, a reference point. I'm going to go through these kind of quickly because David covered these. Approach information. And approach information is kind of giving way to more of lane information instead of approaches. But we decided not to change our NMap file to meet the new standard. We're just going to take what we have and we have the MITS software make that translation into the proper J2735 format. So again, here are more components of it. David mentioned the traffic lane information, lane IDs, lane types, the attributes, which are bit field definitions, of course the lane width, number of nodes, lane node coordinates, number of connected lanes, and of course connected lane identifiers. So how did I go about creating these map files? These are the tools that I used. I use Esri, ArcMap, to put all my node points in. On that map, we have 6-inch photography from Google that is obtained from the state of Utah's Automated Geographic Resource Center. I have to pull that information out of ArcMap, put it into Microsoft Excel, add more information in for the attribute information that's required for the NMap file. I do this through Notepad++ editor. I found that I was having line feed carriage return issues if I used the normal Notepad or other editors, and this one worked the best. And then I wrote an NMap file parser that validates the NMap file that I created. And I did this because in the beginning when we started this project, I would create NMap files, and it's such a manual process that there could be some errors introduced. And the NMap file parser, and I was handing these files off to our contractor who was reading this in the field, and then come back and say something isn't right here. So now I validate my maps before I give them off to our contractor. So the workflow, and David kind of had that in one of his slides, so I'm going to give it to you the way we do it at UDOT. I go through and I create road intersection reference points and lane nodes in ArcMap using that Google imagery. And the question that we had is, when I'm creating these coordinate points, how accurate are they? So I created a few intersections, and Blaine Leonard, who sits right next to me, hired a survey crew to go out and take the coordinates that I created and verify them. And we found out that they were right on the numbers. There was one intersection they found that I was off, and I determined that I was using old imagery. And when I got the correct imagery in, corrected it, no problem. So in our case, ArcMap and Google imagery worked just fine for getting the accuracy that we needed. So once I have the nodes in, I export that reference point and lane node data into a Microsoft Excel spreadsheet. At that point, I add additional information that's required for the NMap file. Then that data is transferred to the actual ASCII NMap file, and that's where I'm editing it, making sure it's in the format that our MIT software requires. Again, after I'm done with that, I validate it, run it through my parser, looks great, and then I send that off for use. Very manual intensive process that would love to see improved, because I don't want to spend all my time doing data entry for the rest of my life. So here's an example of an Esri ArcMap for one of the intersections on Redwood Road. And you can see the node points that I've dropped in there. I've got the reference point at the center of the intersection. We labeled these based on lanes, the point in the lane, and how many node points are in that lane. Such as on one of these east legs, you see lane 1.1.1 is one of the node points. You go back, it's 1.1.2, and follow that nomenclature. I export the data to the Excel spreadsheet, and you can see here I've got my lane nodes information, the coordinates for those points, and then here's your connected lanes that David mentioned. So in this case, lane 1.1.1 connects to two lanes, 6.1, which is straight, and 8.1, which is right turn. It's an approach, not an egress. The lane attributes, you can see that field, that's a bitmap. And each one of those bits determines, as David mentioned, is U-turn allowed? Can you do a right turn, a left turn, protected left turn? I have lane IDs that are used, lane width. So all that information is what is needed to go on the NMap file. Here's the example of the lane attribute bit field definitions. And I had a really hard time getting this information. When I first started this process, a year and a half ago, 2 years ago, just trying to track down what these bits were and how they're defined. And it was kind of like the Rosetta Stone. Once I got the document I needed, then I could just move forward with it. So I created a spreadsheet where I had my definitions preset, so it would be very simple for me to go take that information. Here is the NMap file in Notepad++, the editor. And you can see the information, and this is a human-readable form, so it's very easy to go back and check to see if I got everything. And this is what I validate through my file parser to make sure everything's great. And then here's just another view of it, of what all this information looks like. And this is the kind of information that David described as far as what is required when a map data payload is created for sending across DSRC. Here's just what my output looks like from my validation. I go through and check all sorts of things, making sure lanes aren't missed, things match up, many checks. Here's an example of a small road intersection. This is one I showed earlier, where we don't have a lot of lanes, so not too bad to do. Here's an intersection that probably had about 26 lanes, maybe to 30. So this comes into the size of the intersection is an issue because the 1,300 bytes that are allowed in the map data payload comes into play. And when we first started doing this, we were exceeding that number. And one of the reasons we exceeded it is because we were using full coordinates, latitude and longitudes. We don't use offsets. So what are some of the lessons learned? Well, based on the experience I had over going and doing these intersections and doing them a number of times, because, again, we exceeded the 1,300 bytes. The other question is, how many node points should I put in a lane? Do I need them every 70 feet, every 100 feet? Do I need one just at the start of the lane and the end of the lane? What about a curve? How many points do I need so that the chord drawn between points does not go into another lane? So documentation is really needed. I spent a lot of time trying to find out information. I searched the web about the NMap file, where the attribute fields are, again, the load, the number of nodes, other little gotchas that kind of would bite me when I wasn't expecting it. One of the things that would really help for someone creating map information is what's the best practices manual for creating map data. And I know David mentioned in his some of the documentation that's coming along, and this would be wonderful if you could have this kind of information at your fingertips when you're dropping in these points to document what the intersection geometry is. The second item I mentioned, again, 1,300 bytes. Knocking down the node points helped. We also found that the UPER data compression really helped a lot. But we have larger intersections coming along, and I'm looking at going from absolute coordinates to offsets. The manual process could be speeded up by using software to automate some of the tasks in creating this NMap file. In our case, we're looking at, do I bury a lot of that information in an Esri shapefile instead of creating that intermediate spreadsheet, and then we just have software that would read that shapefile and from that shapefile create either the NMap file or directly create the binary information that's required for the map data packet. So I want to talk about intersections that are under construction. On the Redwood Road corridor that we had, I didn't have too much of a problem because the intersections were all done. I had a few intersections where I had old photography imagery that the intersections were old intersections, and I was able to get new photography that cleared that up. But we have a project going on in Provo, Utah right now for a bus rapid transit project. We got 47 intersections. They're going to have DSRC. The corridor is 12 miles long, 3 to 9 lanes per intersection. We're using Econolite Cobalt controllers. We've got full fiber connectivity, and again, the goal is to be at 97%. The problem that I have with this corridor, and here's a picture of the corridor, that the 11 miles of it, is that some of these intersections, this is what the photography looks like. The road's ripped up. So where are the lanes? Where am I supposed to put the node points? So in this case, we have plan sets that have this information. And so I can go and get this, but yet it's not on my imagery. I can't overlay this. So I went back to the contractor, and they have this information in MicroStation. And we were able to convert MicroStation into KML files, and then the KML I could bring into ArcMap. And when I did this in this case, we found out there was a little bit of discrepancy in what their coordinates were when they did the conversions. But in ArcMap, I'm able to kind of nudge their layer over and get it to where it needs to be. But again, getting this information from the right people and determining what do I do when I don't have good photography is, now that I have this overlay, that's what I'm using to create my node points. So what are the future needs based on my experience of banging my head on the wall or finding something that really makes my job easier? So again, Best practices guide for collecting intersection geometry would be wonderful. Best practice guide for creating the map data. Some methodology for automating getting this map data created. And when back in February when we had the meetings here in Salt Lake, Chris Stanley, who's going to be presenting next week, and he's from Leidos, gave a great presentation on the FHWA map creator tool that will be presented next week. And a lot of things would make my life a whole lot easier being able to use that tool. But some of the issues is I would be using the same imagery that I have or the imagery that they have in their app. And in this case, I still had roads that were ripped up. And we mentioned to Chris some of the issues and enhancements we would like to the system. And one is, can we overlay plan sets on there like I did so that I can actually drop my points in. Their tool would, you drop the points in, you enter information, and it creates the binary information that's required. So that could eliminate a number of my steps. The other thing that you need is validation of the map message data. And David mentioned this a little bit, and I know in Chris's tool they have that or they're working on it, that when you create this, you have to make sure that what you created is proper, so that when we hand this off to our people who are using this map data, it's not going to break the software or they're getting bad information. And one attribute that we really like about the map file is that it's human readable, because if you've looked at that 2735 standard, it can be pretty daunting when you start looking at all the information of what's supposed to go in there and the binary information. And having this ASCII file, when you need to go back and look at it, you can determine, oh, something's wrong here, or this binary value isn't correct, maybe an attribute. So either dumping out, once the payload is created, if it also create maybe an XML or a JSON file, that you could read that if necessary to determine if things are kind of screwy. And the NMap file, in my opinion, and also Larry had kind of agreed with this in February, is kind of an old technology, and it really should be disappearing. And I'm hoping that as new tools are created, where David mentioned, many of these tools are coming along, that this could replace a lot of this manual process that has been taking place. Blaine mentioned in the start of this webinar that there are many ways to create map data, and there are. It's just we need to find ways that are efficient and handle cases where you don't have good information or your imagery, it doesn't match what's really on the road. And once we can figure out those kind of oddball cases, I think a tool would be wonderful to have. Computer vision is another one. And that's where we kind of need to move with map data creation. And here's some of the documents that I referenced. And I think that's it. And I'll hand it off to Greg Larson.